Hi, my name is Adams, and today I'll be presenting my Space Station Commander OS project. The goal of this assignment was to create an interactive command system that demonstrates the core principles of object-oriented programming in Java. Throughout this project, I use abstract classes, inheritance, interfaces, polymorphism, upcasting, safe downcasting, dynamic binding, and user input. I'll start by explaining the overall design before demonstrating how each command works. The first thing I created was my abstract class called crewMember. I chose to make this class abstract because the assignment specifically says that a generic workforce member should never be directly in other words, it doesn't make sense to create an object that simply a crew member. Every crew member should either be an astronaut or a robot. Inside the crew member class, I store one shared piece of information, which is the crew member's name. I also created an abstract method called perform shift. Since the method is abstract, every subclass is forced to create its own implementation that allows every type of crew member to perform its shift differently. Next, I created two subclasses. The first subclass is astronaut. Astronaut extends crew member, meaning an astronaut is a crew member. The second subclass is drone. Drone also extends crew member. Since both classes inherit from crew member, they automatically inherit the name variable and get name method. Instead of rewriting that code twice, inheritance allows me to write it once inside the superclass and reuse it. This makes the code shorter, cleaner, and easier to maintain. Each subclass overrides the perform shift method. For astronauts, perform shift prints that they are conducting scientific research and orbital observations. For drones, perform shift prints that they are performing automated maintenance and heavy lifting. Even though both classes have a method with the same name, each one behaves differently. That method is overriding. Next, I created an interface called diagnostic capable. This interface only contains one method called run diagnostic. The drone class implements this interface because drones are computerized systems that can run diagnostics. I also created another class called life support system. Life support system does not inherit from crew member. It is completely unrelated to astronauts and drones. However, it still implements the diagnostic capable interface. This demonstrates one of the biggest advantages of interfaces. Two completely unrelated classes can still promise to perform the same behavior. After creating the interface, I created the diagnostic scanner class. Instead of writing one method for drones and another method for life support, I wrote only one method. That method accepts a diagnostic capable object. This means the scanner doesn't care whether it receives a drone or the life support system. As long as the object implements this interface, the scanner can perform the diagnostic. This is called programming to an interface, and it makes the program much more flexible. Inside the main method, I created a single array list. Instead of creating one list for astronauts and another list for drones, I declared the array list using the superclass type. So the list is an array list of crew members. Whenever I create an astronaut or a drone, Java automatically stores it as a crew member reference. This process is called upcasting. The advantage is that I only need one collection to store every worker in the station. One of the biggest concepts in this assignment is polymorphism. Whenever the user types the shift command, the program loops through the array list. Each object receives the exact same message. The program simply calls it perform shift. Java then demonstrates at a runtime which version of the method should execute. If the object is an astronaut, it runs the astronaut version. If the object is a drone, it runs the drone version. This is called dynamic binding. Because the same method call produces different behavior depending on the object's type, this demonstrates polymorphism. The next important concept is safe downcasting. Only astronauts can perform spacewalks. That means the execute spacewalk method only exists inside the astronaut class. Since the array list stores everything as a crew member reference, Java doesn't automatically know whether a crew member is really an astronaut. Before calling execute spacewalk, I first use the instance of operator. If the object is an astronaut, I safely downcast it back into an astronaut object. After that, I call execute spacewalk. If the object is actually a drone, the instance of test fails. Instead of crashing the program with a class expectation, the program simply prints an error message saying robots cannot perform spacewalks. This is exactly why safe downcasting is important. Now I explain each command the user can enter. The first command is add. When the user types add, the program asks whether they want to create a human or a robot. It then asks for a name. Depending on the user's choice, the program creates either an astronaut or a drone object and stores it inside of the array list. The next command is shift. If the roster is empty, the program tells the user that there are no crew members available. Otherwise, it loops through every crew member and calls perform shift. This is where polymorphism happens. The next command is spacewalk. This program asks a crew member's name. It searches through the roster. If the crew member is found and is an astronaut, it safely downcasts the object and performs a spacewalk. If the crew member is a robot, the program prints an error message. If the name doesn't exist in the roster, it tells the user that no magic crew member was found. The next command is scan. The program creates a diagnostic scanner. It then loops through the roster. If a crew member implements the diagnostic cable interface, it sends the object to the scanner. After scanning every drone, the program also creates a life support system object and sends it to the exact same scanner method. This demonstrates interface polymorphism because two unrelated objects are handled through one common interface. The final command is done. This simply just shuts down the message and exits the program. To make sure the program worked correctly, I ran all of the required test cases. The first test case demonstrated the normal operation of the program by adding astronauts and drones, running station shifts, performing spacewalks, running diagnostics, and shutting down operating systems. The second test case checked invalid situations. I verified that the program correctly handled an empty roster, unknown commands, unknown crew types, and crew members that don't exist. The third test case verified safe downcasting. I intentionally attempted to send a robot on a spacewalk because I used the instance of operator before downcasting. The program printed an error message instead of crashing. This provided that my downcasting implementation was safe.